Hello, class. This will be the first of three videos I'll be making for chapter two. We're graphing lines. Um, it's in the book that we're using right now. There's only two sections, 2.2 and 2.3. But in the homework, I've split up the section 2.3 into two topics. First one being slope, the second one being equations of lines. I think it just there's a lot to review in that 2.3, so I think it helps just by kind of splitting up a little bit. Um, yeah, so if you've been watching my videos, you know how this goes. The one thing is normally like each section has its own like lecture notes in Blackboard. For the chapter two stuff. It all kind of flows together, so there's one big document. I think it's like 7 pages worth of examples. Today we're doing first 2 pages and a little bit into the third page. The rest of it will be used later. The overview of 2.2 we're talking today is we're going to get into some like basic, how to view, how to graph lines. The main topic is going to be X and Y intercepts, which X and Y intercepts are the points where graphs cross the line. Those are easily identifiable. And so we're going to be talking about those both in this unit and in next unit. I'm also going to talk a little bit about um, the Desmos graphing app and the TI graphing calculators. And what else? Horizontal and vertical lines. We get started on those. So those are kind of special cases. Um, yeah, and just as a disclaimer, part of me as a teacher says that students should be able to do all the line graphing stuff without a calculator or without an app. It is a bit more basic compared to some of the other graphing we're going to be doing later, but everybody is allowed to have a graphing calculator for this course. And I know those are expensive, so that's why I'm going to also be talking about the Desmos graphing app because that's free. And so ideally, I would like you to wait until chapter three and then the next unit to use it, but it's a tool at your disposal. So yeah, so you can use it. But if you're going to use it, we want to make sure you can use it right. So at some point, I'll probably have separate videos on just how to deal with the tools on those. Um, but but they will pop up as part of the video. All right, well, let's get started. So as always, I'm drawing these from the lecture notes I'm posting. Now there's a study guide for Unit 2 resources in Blackboard. So that's where these handouts are. All right, so let's start out real basic, and I apologize in advance for the app that I use to get all my examples made. When it comes to the graphs, it does not let me blow them up bigger, so they're going to be a bit hard to read, and I apologize. Hopefully, if you got them printed out, that might help a little bit. But I will say in MyMathLab, the graphs are big enough to be readable, and you can zoom in and out on those. So that helps. But let's start with just very basic plotting points, or we should call those ordered pairs to be more mathematically um, correct in our language. But ordered pairs are points. The whole reason we call them ordered pairs is anytime you're graphing in the rectangular coordinate system, you have to always have x first and y second. Um, yeah, I'm gonna have to take off my reading glasses to be able to read this. So let's just, that's a warm-up exercise. And so the way that we label points is we tend to use capital letters out in front of them. So if I'm looking at capital A, let's see if I can zoom in real close. Okay. Yeah. All right. There we go. You might actually be able to read that. Okay. So what are the coordinates for A? Yeah. And so remember, it's always X first, Y second, X is left. Okay. I guess I should back up real quick. The X-axis is our horizontal number line. And on the left is our negative values, and the right is our positive values. Our Y-axis is our vertical axis. That's a vertical number line. So as you go up, it's positive. As you go down, it's negative. What else in the? Oh, if you're going on to trig, you may occasionally hear talk about quadrants. It's not. That's more of a trig thing with a unit circle. It comes in really handy. We don't really use it in algebra, but it starts with quadrant one up in the upper right, and then you go counterclockwise. So that would be quadrant two, that would be quadrant three, and that would be quadrant four. It really comes down to like the positive and negativeness of the x and y. So like up here in quadrant one, x and y are both positive. Here in quadrant two, x is negative now, but y is still positive. And then quadrant three, they're both x and y are negative, and then quadrant four, x is back to being positive, but y is still negative. So if you ever, if you see anything about quadrants as you go through the homework, that's what they're referring to. Like I said, that's more of a trig thing. All right, so let's see if we can label all these points. So what is A? So we went left 2 and then down 5. So A would be -2, comma, -5. And then where's B? B is over here. So what's the coordinates for B? If you haven't done this in a while, the most common mistake with labeling points is getting the X and Y backwards. So just watch out for that. So B is going right 3 and then up 4. And I don't know what the psychology is on this, but for some reason, if one of those is 0, students are far more likely to get them backwards. I'm not for sure why that is, but it's just I've been seeing this for years. So just watch out for that. So like on C, what are the coordinates of that point? Well, we went left 3. We didn't go up or down. So x is -3, y is 0. Similar idea with D, but now we're going to the right. And so we're going right 6, and then nothing up and down. So that would be 6, 0. So E is right there in the middle. So what are the coordinates of that point in the middle? Or not moving left or right. So X is 0. We're not moving up or down. So that's 0, 0. And remember that that point has a specific name. And do you remember what it is? It is the origin. That's our starting point for a rectangular coordinate system, is right there in the middle at 0, 0. Okay, so what are the coordinates for F? Well, we're going up 4, and we're not moving left or right. So we gotta make sure to put the X first, which is 0, and then 4 second, because that's how much we go. All right. And then if you have H, what is H? H looks like -4, 7. So hopefully that's a review, but again, review is different for everybody, so that's why we're going over it. Yeah, everything in chapter 2 theoretically should be review. Kind of like the factoring and the solving equations and the quadratic formula stuff was from unit 1. Chapter 2 is our review stuff. Once we get into chapter 3, 3.1 with like the basic function stuff, like domain and range and like what is a function, that's supposed to be review, but the most of chapter 3 is new stuff. So we can start slowing down a little bit then, but this unit 2 is another quick unit, unfortunately. All right. So that's just plotting ordered pairs. How about let's go ahead and talk about the graphing a little bit. Oh, I can spell correctly. All right, so I mentioned Desmos graphing first. Let me do the graphing calculator first, and then then I'll bring up Desmos. So if you have, pretty much any version of a TI 82, 83, 84, all these basically work the same. If you have anything like the Inspire, the higher you get, like the more extra stuff they have that we're not going to use. So for this class, what we're really using the graphing calculator and the Desmos graphing app for is basically just so we can look at our graphs and see what's going on. Right? Um, you can use them for more than that, but for our purposes, like just especially if you're a visual person, I think it really helps to see graphs because the graphs are visual. All right, so how do you graph something in a graphing calculator? Well, I'll start with y equals up here in the upper left. Now you could graph multiple things. The newer ones even graph the different graphs in color. The older ones, every graphic can be the same one, but it does kind of like, even if there's not in color, like whatever you have for graph one, graph two, it will graph them in order so you can kind of see it as it comes up on the screen. Um, but one of the things with the graphing calculator is everything has to be solved for y equals. Right? And that's one of the reasons why we did the formula section on the first test, is so that you kind of get used to solving for y equals. Desmos graphing is actually a little bit more flexible there, but in a graphing calculator, everything has to be, y equals. So I've put in just a basic line here, negative 2x. Oh, let me just start from the beginning. All right, so if I want to do negative 2x, anytime you're doing negatives up front, make sure that you use your negative button, not the subtract button. And so how do you get the variable? Right here, right next to alpha. That x, the t, that's your variable button. Okay. I want to make it minus 2x. Right. And then, the normal operation stuff you type in. So there's a negative 2x plus 3. Okay. Depending on how much you remember about lines, you may already have a good idea what that looks like. If not, that's why we're doing this section and 2.3a is to kind of go over that. So how do you see the graph? Well, pretty much if you're graphing, what you want is up there along the top line. And so if you go over here to the right-hand graph, it draws the line. So, that's nice to have the graph, but we're generally going to need more detail. And so like, notice there are no numbers on that graph. Okay, so what are we actually looking at? So if you look down there, number two, one of the notation things that you need to be comfortable with is what we call the window. So the window, and this language really is geared towards the graphing calculator. The window tells us how far left, how far right, how far up, how far down, and like what those marks are counted by. Okay. And so the language that we use with the graphing stuff, if we have x min as a subscript, that's the farthest left side of the graph. If we have x max, that's the far right side. And then if you see scale, SCL, the scale is the distance between the tick marks. Right, so just because, most of the time, we're like in X, we're going to be counting by ones, but we don't have to be. And very often, when we get down there to talk about the Y's, again, the Y min is the lowest value, the Y max is the highest, the Y scale is the difference in the tick marks in the Y direction. The scales in the X and Y direction can be different because once we start getting into big numbers, like our Y scale doesn't have to be one. A lot of times it could be 10, it could be 100, it could be 1,000, right? Whereas a lot of times the X scale is going to stay at 1. Well, how do you know what all that information is on the graphing calculator? If you come back up here to the top row, to the second one is window. And so it's going to tell you exactly what the window is. So when it says X min is negative 10, X max is positive 10, and you go back to the graph, it's telling you it's negative 10 on this side, positive 10 on this side. And then the X scale is 1. So that means all those little marks are counting by ones. So that's 1, 2. So that line crosses the X axis somewhere between 1 and 2. Same way with the Y. So the Y min is how low the graph goes, Y max is how high it goes. And so this tells us the scale is still counting by ones. So this is the default window for the graphing calculator. Ignore the res and all the rest of that stuff. We're not you don't need to mess with that. Um, if you ever need to change it, you can actually come in here and manually, like if I want to go from -5 to +5, I can go in there and change it. Yeah, so now we're kind of zooming in a little bit in the X direction. Um, if you're ever playing with this and you want to get it back, let's see if I remember. So if you go over to zoom and zoom standard, what zoom standard does is that puts your window back to like the +10, -10 in all directions. Right? But you can also, you can zoom in, you can zoom out. So you may want to play with this. Um, because sometimes you need different, like, let's see, for example, I'm going to go down and put in, let's see. So I want to do x squared. No, I want to do, yeah, let's just do x squared plus 20. And something else in the graphing calculator, notice that I've moved the cursor over to the equals. I got the cursor on the top equals. I've hit enter and move off of it. Notice that it's no longer highlighted. So what that means is my graph is only going to graph that x squared plus 20. But I go over here and I can't see it. Right? Well, this is where, like, particularly in Unit 3, those graphing calculators are gonna have to learn how to play with them a bit. So there is a zoom out, which does like you think it does. There's also a zoom fit all the way down there at 10. What that does is it finds the graph and gives you a picture, but what are we looking at? Then you have to go back to the window and kind of see what you're looking at. Okay, so it's still -10 to 10 in the X direction, but now the Y direction is starting at 20 and going up to 120. I personally always like my mins to be negative. That way I can, and my maxes to be positive. That way you can see like the X-axis and the Y-axis. Now notice how like all that's a solid line. That's because our scale in the Y direction is 1. And we've got some big numbers. So like if I changed it to say 20, now you're going 20, 40, 60, 80, 100. All right. So for those of you with graphing calculators, this is something you're going to have to learn to play around with if you want to get the most out of it. This section, chapter 2, we're dealing with lines. Lines are a little bit more straightforward. When we get into transformations, it'll be helpful to know how to play around with this. So um, there's a lot of good videos out there on how to do graphing basics. Um, but when I'm doing my videos, most of the time I'm going to be doing Desmos graphing because that's more people have that because it's free. But that's, whatever tool that you're using for the graphing, make sure you know how to use it. So I go back to zoom standard. Now I'm in 10 to 10, both directions. And I'll go to Y equals. I want to clear that. I want to turn that back on and then. All right. So that is the graphing calculator, just really basic. So how about the Desmos graphing? So it's spelled just like it sounds. All right, so what you can do is and let me just walk you through this. All you do is go into Google, do Desmos graphing, and the first one that pops up is the graphing calculator. And so that's what this looks like. Now notice that it does have numbers on it so you can see it. Like we graphed in here, we did y equals -2x plus 3. So I could type that directly in and notice, and then I get that same line we looked at before. Notice that if I come up here and don't put the y equals, it still gives me the same line. So like I said, and if it's not solved for y equals, Desmos can actually still graph it. We'll do more of that a little bit later. All right, so the nice thing about the Desmos graphing is like we had to play with the zoom buttons before. Here, I'm just scrolling my wheel on my mouse and zooming in and out. Okay. Or if I like click on it and hold the left button, now I can like drag it and move it around. Yeah. And so there's a lot of things that you can do in both the graphing calculator and the Desmos. So like here, I clicked on the gear, the edit list, and I can create a table. And what it does is it pops out the table for me. And this is kind of where, as a teacher, I want you to be able to do this yourself. But I know that this is a tool you have, so you might want to play around with it. You can do the same basic thing on the graphing calculator. It's a little bit more work. Um, but this is like if you just need to be able to see a graph, like if you're not for sure if you're doing it correctly, then pop this in here, see what it looks like. Let's see what else. Like here, you can see the window. Like again, I think the default on these is still the -10 to 10 in both directions. But now you can actually see the numbers. Like here, the scale is 2 in the X direction because you're counting by twos. Same in the Y direction. You can actually zoom in, zoom out. How do you like that? If you go in the graph settings, then you can actually like type in what you want on the left and the right and the top and the bottom. So again, like whichever tool you're going to use, start playing around with it, get comfortable with it. Like I said, we're gonna use this more in chapter in 3.4 when we do transformations, because we're gonna be talking about a lot of different types of graphs. Hopefully for the lines, this is more just of a backup for you. But later on, it definitely comes in more handy. But you have the Desmos graphing and your graphing app. Desmos graphing app is completely free. So there's that. All right. Let's get back to the actual notes. So if I was to ask you what equation of the line do you remember? Typically what most people say is y equals mx plus b. Right? That's what we call the slope-intercept form. The reason we call it slope-intercept form is the m is the slope and the b gives us the y-intercept, the y value of the y-intercept. All right, so we're going to talk about slope in the next video because that's 2.3a. We're going to talk about the y-intercept. That's one for today's topic. Something else that you'll see occasionally is the general form. This is not solved for y equals. The x and the y are on the same side. In terms of like being able to graph it, the slope-intercept form is much more useful, but often like our problems will start with general form. And this is useful for other topics, like if you ever do matrices, things like that, you're going to see this form more often. I will talk about the point slope form in 2.3b, but when we start talking about equations of lines, this can be helpful. There's also a slope formula. The m equals y2 minus y1 over x2 minus x1. That rings a bell. That's going to be in the next video because that's 2.3a. But I just kind of wanted to throw those out there. We're going to use this a lot more in the 2-3 stuff, particularly at the end of the slope and then at the beginning of the 2.3b. So that's where we'll see most of this. All right, so we're talking general graphing stuff today. So let's talk about the intercepts. And so intercepts are where the point where it crosses, x-intercept is where it crosses the x-axis. And to cross the x-axis, That is our x-intercept. So to cross the x-axis, that means we can't go up or down. So what that means is y is always 0. Okay. So to cross the x-axis, y must be 0. So every time you're doing an x-intercept, y has to be 0. We don't know what x is. That depends on the graph or the equation, but we know y is 0. The flip works for y-intercepts. So the y-intercept is where it crosses the y-axis. Now, to cross the y-axis, that means we can't move left or right. So for all y-intercepts, now x must be 0. And so if we're writing in point form, then x has to be 0, and then we figure out what y is. The way I remember this is when we're dealing with intercepts, the opposite one is equal to 0. So for x-intercept, y is equal to 0. For y-intercept, x is equal to 0. Now, one thing I do want to point out, intercepts are points because it's points where it crosses the line or the axis. Um, Sometimes in MyMathLab, they want just the x value or just the y value, which kind of annoys me because, once we get into horizontal and vertical lines, I'll explain it a little bit more. But if you just say x equals or y equals, those are not points, those are lines. Okay? But just make sure you're watching the instructions in MyMathLab. If they say as an ordered pair, that's the fancy word for point. So make sure you're putting them as points. If they want, if they don't mention ordered pair, then they probably just want the x value or the y value, depending on which intercept you're talking about. So, MyMathLab's not always consistent on that. So just make sure you're reading the instructions. All right. So let's start with the graph part. Zoom in here again. Voila. All right. So we're going to list all the x and y intercepts of the graph. Now, sometimes I can't remember. I think some of the problem, I really wish in MyMathLab, they would say, like, what are the x-intercepts? Give me those. And then like the second part, give me the y-intercepts. I think on at least some of these, they don't make a distinction. They just want you to list all of them. So in the notes, I'm just gonna um, separate them out. But just know in MyMathLab, they may have you write all of them together, just separated by commas. All right, so let's start with the x-intercepts. So how many x-intercepts does this graph have? Well, where does it cross the x-axis? It does it twice. Oh, I probably shouldn't have made that mark there because now it's going to be hard to read the numbers. Sorry. Right, so what is the coordinates of that x-intercept? Well, before I cross it out, it looked like x is 3. And for x-intercepts, y are always 0. Now we have 2 of them, so put a comma in between them. Again, if you don't put that comma between them, MyMathLab will probably count your answer wrong. So what are the coordinates of that second x-intercept? It looks like 5, 6, 7. I think it should be 8. Again, I apologize for putting the. And so x is 8, and now y is 0. Now for the y-intercept, there's only 1. And so where does it cross the y-axis? It's above 10, 11, 12. It looks like maybe 13. Like I said, in MyMathLab, you're going to be able to see this with more detail, and you can zoom in and out. So let's just assume that that's 13. That's the y value. So what's the x value of the y-intercept? Remember, opposite ones are always 0. So for y-intercept, x is 0. And if MyMathLab, if they didn't separate these out, you would just list all 3 of them. You wouldn't run them out of the order. Make sure there's commas in between. Okay, so here's a circle. What are the x and y intercepts here? Again, for the notes, I'm going to separate them out. So now we have 2 of each, right? So for the x-intercepts, what are they? So over here at -7, and then y is 0 because we're not moving up or down. So there's the left x-intercept. The right intercept, 5, 6, 7, yeah, that's 7. Again, the y is 0 for the x-intercept. So those are my two x-intercepts. And then for the y-intercept, we have two of them. So the lowest one looks like -7. So make sure that you're getting your x's and y's in the right spot. So the y is -7, x is 0, because we're not moving left or right. And then same idea for the top one. Now that goes through y is 7, that x is 0. Okay. Like I said, once you kind of get used to, like I said, the most common mistake with the x and y intercepts when you have a graph is getting the x and y backwards. And again, I mentioned that for whatever reason, when one of these values is 0, people tend to get them backwards more. So just watch out for that. Again, x-intercepts always have y equals 0. Y-intercepts always have x equals 0. Okay, here's a nice little question. Because now we don't have any numbers on the graph itself. So what are the coordinates of these points? Again, let's do the x-intercepts first. I'm getting bleed through on my pins from the other side, apologize. So for the x-intercept, I always like to go, it never hurts to go from left to right anytime you're talking about stuff like this. So on the left, what is the coordinate of that point? How do you know? Because if you tell me -2, 0, you just got it wrong. So this is where we talked about the window. And so what that tells you is that, this is -8, that's +8. Now there is nothing on the scale, but you have 1, 2, 3, 4 tick marks. And so how do you get to -8 in 4 steps? We have to be counting by twos. So that's -2, -4, -6, -8. So that x value is -4. Okay. And it's crossing the y-axis, x-axis, so y is 0 because you're not moving up or down. And then for the second one on the right, and everything we've done so far has all been symmetrical. I could give you a weird shape, and so it wouldn't have to be like -4 and +4. It's just whatever the shape gives you, you go with that. Right, but this is symmetric, and again, we already discussed we're counting by twos, so that is going to be x equals 4, and again, y is 0. Now, what about the y-intercept? Now, we're going to 6. We've got 3 tick marks, so 2, 4, 6. So we're still counting by twos. Note, remember, we don't have to count by the same amount each direction. We can count by twos in the x direction and like ones or fives or tens in the y direction. But that's why it's important to know, what those numbers mean. So 2, 4. So that's at y equals 4, x equals 0. Y-intercept would be 0, 4. All right. And once you kind of get back into this, the reading the intercepts off the graph is kind of the straightforward part, as long as you're not getting your x's and y's backwards, which can happen, like I said, more often when you got those 0 values. All right, let's look at some algebra. I don't know why I have two i's and y-intercept. So what do we want us to do? So graph the linear equation by finding and plotting its intercepts. So quick question, how many points do you need to graph a line? 2. Right? And you can graph more, but the tool in MyMathLab only has 2. If you try to plot more than 2, then it's thinking you're starting, like if you try to graph 3 points, it's going to think that third point is the start of a new line. And I'll bring up the MyMathLab and kind of walk through those tools, but you don't have to have the intercepts in general to plot a line, but I can tell you right now, unless they've changed their algorithm, that if MyMathLab says plot it, graph it by plotting intercepts, the 2 points it wants is the intercepts. If you use some other points, it's probably going to count it wrong, even if you have the same exact line. But just be aware of that. That's something MyMathLab, like I said, unless they've changed their algorithm, is very picky about. So one thing I like to do when I'm plotting points or generating points, I like to do what I call a t-table. Yeah, and since we're doing intercepts, so what do we know about every x-intercept in existence? Well, every x-intercept has y equal to 0. And then what do we know about every y-intercept? We know x is 0. This is the x-intercept. This is the y-intercept. So I like to put my data in t-table form. So how do we get those numbers? Well, this is where, again, you have to know for x-intercepts that y is equal to 0 or you can't get started on this. And so what we do is we go over to our formula equation and plug in y equals 0, solve for x. I'm running that over here. They go on the paper. So we'll do open at number 8. We have negative 2x minus 4y equals 8. So right now I'm looking for the x-intercept. The x-intercept, first step is you're going to plug in y equals 0. Again, I'll say this multiple times. It's the opposite, for intercepts, the opposite one's equal to 0. For x-intercept, y is equal to 0 and vice versa. So we come up here, plug in y equals 0. And it's one of the nice things about finding intercepts is you're plugging in 0, makes the math a little bit quicker usually. But you could plug in 1 or 2 or 3, but then it's going to have a little bit more work, and you're more likely to get fractions when you plug in something other than 0. That goes to 0. We got negative 2x equals 8. Right, so this is basic solving stuff. You're going to have to solve a lot of equations at this level. Get x equals negative 4. So for my x-intercept, x was negative 4, and we got that by plugging in y equals 0. So how do we find the y-intercept? Well, y-intercept, same idea, so now we're plugging in x equals 0. So we got negative 2 times 0 minus 4 times y equals 8. Well, and then we're right back to solving a basic equation. That goes to 0. We get y equals negative 2. So we plugged in x equals 0, got y equals negative 2. So now how do we graph this? And again, I'm going to bring it up in MyMathLab and show you how the tool works. But let's do at least one of these by hand. What numbers do we need? We need up to negative 4, so let's just count by ones. All right, so plot your points. So we have negative 4, 0. So that means go left 4, don't go up. So that's our negative 4, 0 point. And then 0, negative 2. So 0, negative 2 for our y-intercept says we don't go left or right, we just go down 2. And then you connect the dots. Right. That's, and like I said, if you had done different points, like, I don't know, like if you had got that point or if you got that point on the line, notice that those points still make the same line. But MyMathLab, if they say specifically plot using intercepts, they're basically checking for that. And I think I tried to pick problems where they actually ask for it explicitly, but you're going to see some that don't even ask you for the actual numbers. They just say graph it. Right? But when in doubt, it doesn't hurt to plot your intercepts. Okay? So that's the key is x-intercepts plug in y equals 0, y-intercepts plug in x equals 0. Okay, I want to do one more of these by hand, and we're going to talk briefly about horizontal vertical lines, and then we'll get into the MyMathLab tools. All right, so the next one is y equals 1/5 x. And so we're going to graph it using the intercepts again. And again, I like to do this in t-table form. So for x-intercept, we want y equals 0. For the y-intercept, we want x equals 0. Okay. Let's do the x-intercept. So we're going to plug in y equals 0. Okay, so how do we solve 0 equals 1/5 x for x? This is why we talked about fractions. This is where you can invert and multiply. It's a 1x, and 0 times 5 is 0. So we get x equals 0. Do we need to do calculations for the y-intercept? No, because if I plug in x equals 0, I already know y equals 0. Or if you put, or if you look at it, 1/5 times 0 is 0. So what this means is this line is going through the origin, and it doesn't have a separate x and y intercept because it's the same one, right? So when this happens, you need a second random point. Because you can't graph a line with just one point. So here's the question. Typically, I mean, you could plug in y, figure out what x is. If it's solved for y equals, plug in x, figure out what y is. Now here's a little tidbit. MyMathLab doesn't like fractions when it comes to graphing. Um, if I've got the tool turned on, you should be able to graph it. There's a way to graph fractions, but let's just try to do it without fractions for now. Need to pause right quick. Okay, I'm back. Okay, yeah, so this is the one point in MyMathLab where you any point will work. Um, it can't be just the intercept. And so the question is, what x can you pick to make your life a little bit simpler when it comes to the arithmetic? Because if you do random x's, like if you pick at x equals 1, 1 times 1/5 is 1/5, you're going to get fractions. So how can you avoid fractions? Well, pick multiples of your denominator. So since we have a fifth in here, I would pick 5. Maybe you could pick -5, or you could pick 10. Just any multiple of that number would work. Like if this was like 2/3, I would pick like x equals 3 or -3. If it was 1/4, I'd pick x equals 4, and so on. Just to minimize dealing with the fractions. So we plug in x equals 1, we're going to get y, x equals 5, y equals 1. Now we have our 2 points. Right? X equals 5. So we're starting at 0, 0. So that point counts for both the x and y intercept for this graph. And then when we did x equals 5, we got y equals 1. So we go right 5 up 1, do your point, and then connect the dots. Kind of missed it there, but you get the idea. Okay. Right now, one of the downfalls of only doing 2 points is if you make a mistake and only do 2 points, you're never going to catch it. So for example, if your second point was up here, you're still going to get a line. Wherever that second point is, you're always going to be able to draw a line. So sometimes it doesn't hurt to have a third point to just check and make sure, like, is that point on the line? But like I said, MyMathLab only do 2 points because if you try to do a third, it thinks you're starting a new line. All right, so just to recap for the intercepts. All right, so x-intercept is the points where it crosses the x-axis. The y-intercept is the points where it crosses the y-axis. And don't forget, like, this is something to kind of burn into your brain. For x-intercepts, y is equal to 0. For y-intercepts, x is equal to 0. If I can get nothing else from you from this video today, that would be the main point. All right. So before we get into MyMathLab, let's talk a little bit about horizontal and vertical lines. One thing with horizontal and vertical lines, most lines will fit in that y equals mx plus b format, that slope intercept, because there's going to be a y and an x. Right? But horizontal and vertical lines are kind of special cases. Okay. So let's start by doing a t-table for x equals -5. So I need 2 points. Right, so if you try to do, say, an x-intercept, that would be y equals 0. Where do we plug in y equals 0? There's no y in the equation. Okay. So we can't pick y's and figure out what x is, because there's no y to plug in. So let's try and see what happens when we pick an x. So give me an x that you think works for this, that you would like to try to plug in. What if you just say, let's say you want to try to plug in x equals 0. Right? Well, if you try to plug in x equals 0, you get 0 equals -5, which 0 doesn't equal -5, so that's not going to work. You can't plug in x equals 0. So what does this equation tell us about this line? It's very explicit that x has to equal -5. So the only x we can use is -5. So I don't care how many points we have, every single one of them has to have -5 for x. So how do we figure out the corresponding y? Well, here's the sort of the trick on this. I don't know if trick's the best word, but maybe the idea. If you had an equation with only x's, then y can be anything because there's no constraint on y's whatsoever. Whereas like in the other one that we did, once we picked an x, then y was dependent on whatever we picked for x. Or vice versa with if I picked a y, then x can only be that one thing. Same way here. Now, once you pick an x, y, the value of y depends on what you picked for x, because there's both an x and a y in the equation. But if there's no y in the equation, that tells you y can be anything. So y could be 0, y could be 3, it could be -100, it could be 1.26789. Y can be anything because all this tells us about this line is x has to be -5. All right, now before I plop this down, so I'm telling you that one of these is horizontal and one of these is vertical. Which one do you think is which? Well, the common thing I get is, well, the x-axis is the horizontal axis. So if I have x equals -5, that's going to be a horizontal line. It's actually backwards. Yeah. So, it's one reason I like doing horizontal line, vertical lines here, like for the x and the y intercepts, the opposite ones equal 0. Well, it's kind of backwards here too. And so what's happening is if you plot these points, so there's our -5. So -5, 0 is right here. And then -5, 3 is up here. So once you plot those points, you can see that they're vertical. So if x is this, because so every single one of these infinite points on this line is going to have x equals -5. So if you have x equals a number, that is always vertical. So what about y equals 3? Let's do a t-table for that. So what do we know about this line? Well, now that we've done the first one, it tells us y has to be 3. We have no choice on y. I don't care how many points you have on y, every single y has to be 3. Now, how do we get x's? Well, just like before, where there was no y, well, if there's no x in here, that tells us x can be anything. It's only when you have a y and an x in the equation that, once you pick x, there's a specific y. Once you pick y, there's a specific x. Okay, so for horizontal vertical lines, those are special cases. So x could be 0, x could be, I don't know, -2, +1. X can be anything, but I know y has to be 0. So let's graph these points. All right, so if x equals a number is vertical, that kind of implies that y equals a number is horizontal. The reason it's horizontal, well, there's my first point of 0, 3, and then -2, 3 is right there. So if you get a horizontal line, so because all your y's are the same, you're never going up or down because you're always at the same y. Just like with an x equals, you're never going left or right because x is always the same. So x equals a number is a vertical line, y equals a number is a horizontal line. And it's to your benefit to get that memorized because it's, basically treat horizontal and vertical lines as special cases that don't follow y equals mx plus b. All right. Like I said, this is we're gonna and those are gonna be sprinkled throughout the rest of the chapter 3 or chapter 2 stuff. Um, we do a lot more. If you have a y and an x, then you get a slanted line, up or down, and we'll talk more about that with the future videos. But just x and y, treat those as x equals y equals horizontal vertical, treat those as special cases. Okay. Well, now what I want to do is get into MyMathLab and show you how the tools work for the graph. Mhm. Yeah, now you're gonna have to start scrolling down here a bit. So now, yeah, so 2-2 is what we're talking about today. And like I said, I split 2-3 up into 2 different units to kind of focus on the 2 different topics. Those will be the next 2 videos. And then all of chapter 3. So this is kind of quick because like this week, like all the same week, you need to be doing chapter 2. And then, we get into some of the new stuff. But for now, let's focus on 2-2 homework. Yeah, so there's your warm-up exercise. Just getting the coordinates for the points. Over here on the right, you can zoom in and zoom out. What's this do? Oh, there's okay. That one you can't zoom in or zoom out, but you have your zoom tools to make it a little bit easier to read. Oh, and by the way, they want all of them or just one? Make sure you're using your parentheses. Now notice here that if you're just doing ordered pair, they have that like the parentheses with the 2 blanks. That'll make it a little bit quicker to enter. What is A? A is 3 and doesn't go up or down, so X is 3, Y is 0. Yeah, so they're gonna have you do all of them. Like I said, if you haven't done this in a while, this is a good one. If you know how to do it, this should go quick. Okay, this is the viewing window we talked about. So this is just like general knowledge. So when we say X min, what is X min on the graphs? Remember, X is left and right. So X min would be your left. So X min would be -6. X max is your right side. So in this case, it would be 6. And then the scale is what are you counting by? And so there are 3 tick marks. So how do you go from 0 to 6 in 3 steps? Well, 2, 4, 6. So you're counting by twos. So remember, the scale is what you're counting by. If you get one of these with Y mins and maxes, remember Y min is the low value, Y max is the upper value. Okay, so a couple of those just to warm up. Definitions. Well, here's, define y-intercepts of the graph. Let x equal 0 and solve for y. That is definitely true because remember, opposite ones are equal to 0. So for y-intercepts, you're doing x equals 0 and vice versa. Yeah, notice that you don't get 9 attempts on this. True and false, you only get one shot. Okay. So then you're going to have some where you list the intercepts. Now notice here they didn't distinguish between x and y. And so this would be multiple choice. Hopefully you're eliminating A right away because you have 3 intercepts. All right. So then just go through, make sure you get your coordinates. You're counting by twos because it's 2, 4, 6, 8, 2, 4, 6. Yeah, again, I really wish they would like separate out X and Y intercepts, but all the graphing ones do it this way. So, and like here, there is no y-intercept because it never crosses the y-axis. There's only a single x-intercept, which happens. Right, and here's kind of a definition. So given a graph has intercepts, say -9, 0 and 0, 5, choose the right statement. So this basically want to know which one is which. So when you have that -9, 0, is that the x-intercept or the y-intercept? Well, y is 0, so this is an x-intercept. And that's the only one with y equals 0. So the x-intercepts. Now notice here, this is what I was talking about. They're just giving you the x part of the x-intercept. And then this is the y-intercept because x is 0. So MyMathLab will occasionally revert back to just wanting the x part of the x-intercept and the y part of the y-intercept. But they're really points. All right, I'm trying to get to, I really want to do is do a graphing problem here. Okay. So this is a warm-up problem. So find the intercepts and graph the equation by plotting the points. So how do you find the intercepts? Well, you plug in x equals 0. This is what we did on the previous examples. Plug in x equals 0, figure out what y is, plug in y equals 0, figure out what x is. Once you have those, then you would put them in there and then use a comma to separate them. Okay. So that's what we're doing before. I'm going to skip this one because I want to talk just about the graph. So after you do that, then they're going to have you graph it. So there's a couple of those. So here's one where it says graph the following equation using x, y intercepts. Notice they don't have you enter the x and y intercepts. So this one, you still have to find the x and y intercepts, or it's going to count it wrong when you graph it. What do we have? We have x plus 2y equals 12. So let's get those intercepts right quick. And then that way we can see how the tool works. So for x-intercept, y equals 0. So we're going to do x plus 2 times 0 equals 12. So we get x equals 12. So that point would be Plugged in y equals 0, got x equals 12. And then for the y-intercept, we're plugging in x equals 0. So 0 plus 2y equals 12. We get y equals 6. So we plugged in x equals 0, got y equals 6. All right. So you still have to find them, even though they don't give you a spot to like explicitly put them in like the previous problems did. So how do we graph this? And let's click to enlarge here. See that, I don't know about you, that didn't enlarge it a whole lot, but it helps a little bit. All right. So how do you graph in MyMathLab? Well, we're graphing a line. And so grab your line tool. Right? That's absolute value tool. That is parabola. That's a Cyrus parabola. You can draw circles. And so some of this stuff we're going to use a little bit later in 3.4. We do transformations. But for now, we're just graphing a line. And if you notice on that line, maybe kind of hard to see, but there's 2 points. So what that's telling you is they want 2 points. All right. Oh, and let's see, is it? Yeah, so notice, yeah, so when I didn't enlarge it, as I'm, like you can't, let's see, what does it do? Oh, it starts with the line tool by default. But notice in here in the lower left, like as I'm moving that cursor around, it's telling me where the cursor is. If you're in that click to enlarge, that it's up here in the upper right. And so I want 12, 0, positive 12. So I'm at 12, 0. So then once you're there, you click on it. And then the next point is 0, 6. So I want to go up 6 and then click on it again. And then once you have the yellow line, then there's your point. Okay. Now, let's say that you make a mistake. One of the things you can do is if you click on a point, you can actually drag it. Now, also notice that up here in the upper right, it said edit coordinates. So after you put it in, you can actually like, oh, cancel this. Let's clear all this out. So I'm going back to my line tool. Let's say I know that I messed up on this point. So what you can do is you can click on on that point, come over here to edit coordinates, and you can actually type in, that was supposed to be 12, 0. So if you're having a hard time, particularly if you're trying to do this on like an iPad or something that's small, just put in the points that are close and then click on them again afterwards, and then you can edit it. You can type them in. Like here, I can, oh, and like as soon as I clicked on it, it moved it. Because now it's at 0, 3. So I can go in here and edit. That was supposed to be 0, 6. Oh, and by the way, you can even put fractions. So if you do like the backwards, the slash bar next to the shift, you can type in fractions. That's the only way you can do fractions when you're graphing is put in your points and then come up here and edit the coordinates. I don't want that. Or like I said, you can drag it and notice that as I'm dragging it, it's telling me they're in the upper right or in the lower left if you're in the other screen, where exactly what the coordinates are. So that should help you not get the X and the Y backwards. Okay. And when you're done, just hit save. So that is how you plot points in MyMathLab. Oh, I haven't checked it. Check it. Yep. All right. And so again, like on this one, I'm not gonna go through and plot it, but notice that I'm not clicking to large, so there's no tool palette over here. But as soon as I click on it down below, it pops up. So make sure to select the line tool and then plot your points. And so once you have the first point, so notice that it's in blue. Before I do my second point, as soon as I do my second point, then the points are highlighted in blue and then the lines in yellow. So we're going to use more of these tools later on, but that's what you need to know for now. And you can either sometimes we'll be doing multiple lines here, but so you can if something's wrong, delete it or clear it, and you can start over if you need to. All right, I think that's horizontal vertical lines. For some reason, this tends to mess people up when we're doing it on MyMathLab. If you do it by hand, like if you, well, first of all, you need to know, is that a horizontal line or is that a vertical line? Well, y equals a number says all the y values are the same. So this is a horizontal line. So how do you graph a horizontal line in MyMathLab? So click on the graph, get your line tool. Well, what we know is y has to be 5. So it doesn't matter what points you have as long as y is 5. And it's kind of hidden down here, but a lot of people like to start with the intercepts. And then what happens is they kind of get lost. But if you know it's a horizontal line, go to any other point that's on that horizontal line and you're good. Same if you're trying to do, like say this was x equals 5. So x equals 5 would be a vertical line. So if we're doing x equals 5, click, give me my line. So again, a lot of people like to start with the intercept. So once you have that first point, if you know it's vertical, click anywhere that gives you a straight up and down line. All right, so that's how you draw horizontal vertical lines. Just make sure that the y or the x is correct on both points. Like here, x equals -8. So x equals is a vertical line because all the x's are the same. They all have to be -8. So anywhere on here, I don't have to pick the intercept. I can do like up here and down here. Now I got a vertical line at x equals -8. Okay. Sometimes it serves people off when it's at 0, but that's if you get x equals 0, that is the y-axis because you're not moving left or right. If it was y equals 0, that would actually be the x-axis because all the y's are 0. But x equals is a number is vertical, y equals a number is horizontal. All right. So part of the challenge with this is learning how to use the graphing tools in MyMathLab, and then you know, going through like remembering all the. But that's one of the challenges I think of this unit is the algebra skills are not as I guess hefty as it was in Unit 1 with like the factoring and the quadratic formula and all the equations. The algebra is a little bit more basic, but there's just a lot of like little details in this unit. So that tends to be the challenge here. So you definitely don't want to get behind on this unit because when you start cramming and there's a lot of little details, they all kind of tend to blur together. That's all I have for today. Yeah. Hope this helps, and I'll see you in the next video.